This is a podcast on the nucleotide, and it's a bit of a poser, really. Rather than just talking you through this, I'm going to ask you to see if you can see the more detailed shape of the nucleotide from our basic layout here. Now, we've already, in the nucleotide podcast, I've already talked to you about the fact that nucleotides consist of three separate sections, and there they are: the phosphate group, the pentose sugar, which is a 5-carbon sugar, which is ribose or deoxyribose, and then the nitrogenous base, which in DNA would be A, T, G, or C. I've also talked to you in my podcast about nucleotides about the two types of nitrogenous base that exist. And we can see here that we have got the pyrimidine and we've got the purine. And so the pyrimidines are cytosine, uracil, and thymine, and we can see that they only have one ring. And the purines are larger, and they have 2 rings. You can see 1, 2, 1, 2. So when they base pair, complementary base pairing being the key term, a 2-ring structure goes with a 1. And so cytosine will bond with guanine and thymine will bond with adenine. You'll see here that uracil is left out, and the reason for that, hopefully you know, is that uracil replaces thymine in RNA. So with those two things in mind, the basic structure of the nucleotide and the pyrimidine and the purine rings in your mind, I'd like us now to look at a website called scienceprimer.com. And now what we're doing is we're taking away the labels. So what I'd like you to do is to look at those two structures and see if you can see our basic nucleotide structure and then try and identify whether they would be or what they might be. This is tricky. Can you see any patterns in those two molecules and come up with what they are? Give you a few more seconds. This is tricky because you're translating the very formulaic, boxy structure to something which is much more akin to the way the biochemistry works. Okay, well, you might see at the bottom there it says pyrimidines. So in fact, these are 2 pyrimidines. And so are you able to say what they are therefore if they are pyrimidines? Okay, right, well, let's see if you're right. So if we just click here, we can identify the nitrogenous bases. There they are. And you can see that there's only 1 ring on these. And so therefore, we can definitely say that they are pyrimidines because they only have 1 ring. The deoxyribose is circled there in green, and the phosphate is circled there in brown. So can you see now we've taken those quite complex bonding diagrams and we've identified our 3 areas. Now, if you didn't get that, I don't think you should worry about that at all. But now you can see them there. Hopefully it will allow you to understand how these molecules are in a more realistic way. So, if I asked you to identify oxygens there, do you think you could? Which colour dots are the oxygens? Which colour dots are the carbons? Which colour dots are going to be nitrogens? Well, if we know our deoxyribose structure and our phosphate structure, we can actually see that the red dots are going to be the oxygens. Phosphate is PO4 minus, and our deoxyribose ring has an oxygen in the ring at the top, and we can also see that it's got 1 oxygen because ribose has two, and so DNA is deoxyribose, which has one that moves. So the red are oxygens. The black are carbon. If we look at the ring structure of the deoxyribose in the green circle, we can see carbon 1, which is bound to the nitrogen space, and then going around 2, 3, 4, 5. The blue circles must be nitrogen. The orange circled nitrogenous base has two blue dots there, and they must be nitrogen because they're nitrogenous bases, and we now know that oxygen is red and carbon is black. So the only one there that I haven't mentioned is the yellow dot, and that must be phosphorus, which is bound to the oxygens, the red oxygens in the phosphate group. So taking away these again, can you now see that general pattern? Now if I change this to the purines, got slight difference, but can you see immediately the double ring structures on the nitrogenous bases? If I circle those now, we can see that the purines have two rings, and there they are. Hopefully now you should be able to identify the deoxyribose. There they are. And you should be able to identify the phosphate. There are the sections, and there it's without. Now you don't need to know these full structures, but if you can understand the way that these are put together, then I think it actually helps understand DNA in general. So let's go through some individual ones just to see how you go. So this is adenine, and we should know that adenine is a purine, and we can see the double ring structure, which tells us it's a purine. This binds to thymine, which is just a one ring structure and is therefore a pyrimidine. If we look at guanine, we can once again see the two ring structure, which binds to cytosine, which is a one ring structure. So there's more of a feel for the way that the nucleotides are bound together away from our very basic boxy areas of phosphate group, deoxyribose sugar, and nitrogenous base.